In this video, I'm going to walk you through the steps of conducting a bivariate regression so that you've done a whole comprehensive analysis that will give you a sufficient amount of information to write up a manuscript or a thesis or a report. The first thing that you need to consider is level of measurement. Is it even appropriate for you to do the bivariate regression? So the level of measurement you should be expecting here is continuous and interval ratio. So for example, years of education and amount of earnings are both ratio scales because you can actually earn $0 or you have zero education. But there's also interval type scales like intelligence level, for example, that you could potentially use in a bivariate regression. So you need to take into consideration the continuousness of your variable. And I do mention here briefly that you might have an ordinal scale that is sufficiently informative for a bivariate regression. And I write here at least a 5-point scale for certain as one of your variables in the bivariate regression might be appropriate. So that would be a Likert scale from strongly disagree to strongly agree, for example. This is a bit contentious, and I talk more about that in the non-parametric statistics chapter. I just mentioned it here briefly as a possibility. It's at this stage in step 1 that you should be thinking about which variable is your independent variable, or the predictor, and which one is the dependent variable, the outcome variable, because it's going to have an impact on the results. You're going to want to check for normality, of course, and outliers, and I keep using the same rule throughout the textbook as a general rule: skew less than absolute value of 2 and kurtosis less than 9. Ideally, both variables are skewed in the same direction and in the same magnitude. This rule is based on that notion. There could be some deviation, but as you deviate progressively from the same level of skew across variables, it starts to become worrisome. And for outliers, you can use the outlier labeling rule with a 3.0 multiplier to determine whether you have a potential problem or not. And once you're satisfied with those two steps, you can run the bivariate regression. And once you've run the bivariate regression, you'll be probably especially interested in the beta weight. The intercept does have some importance, of course, especially when you want to create a regression equation. But my hunch is that the vast majority of people are interested in the beta weight. And it's at this stage you're going to have to think about whether it's the unstandardized beta weight or the standardized beta weight that you're especially interested in. You might be interested in both. And you'll want to evaluate whether that beta weight is statistically significant or not. Bear in mind that a statistically significant beta weight implies a statistically significant association between the independent variable and the dependent variable, much like a Pearson correlation. In fact, in the bivariate regression case, the Pearson correlation and the standardized beta weight are the same thing. So look at the p-value. Is it less than 0.05? And also estimate the 95% confidence intervals, either for the unstandardized beta weight or the standardized beta weight, or both. Next, you'll want to check the scatter plot. Is there some indication that the association is linear in the data? Because bivariate regression really only works in the context of a linear association. I talk about nonlinear or curvilinear associations in another chapter of this textbook, and I encourage you to check it out. Most of the time, people will have a linear association in their data, and I'll show you in the examples how I examine that sort of question. Check for normality of standardized residuals. I mentioned that already in the textbook, that there's a way of looking for that. And you should always look for some level of normality and that you don't have any outlying standardized residuals. And then you can test the assumption of homoscedasticity. And I provided at least 2 tests to evaluate homoscedasticity. And one that I kind of like because it's so simple, straightforward, and intuitive is the correlation between the standardized predicted values and the absolute standardized residuals. When homoscedasticity is present, there will not be a statistically significant correlation between the standardized predicted values and the absolute standardized residuals. Now, if you're interested in doing further testing or an alternative approach, you could use the co-anchor test, which is similar to the Breusch-Pagan test. It's up to you if you're willing to do the extra work to do the co-anchor test. Now, if the assumption of homoscedasticity is violated, you're now responsible for estimating adjusted standard errors, because you can no longer trust the standard error from the normal theory bivariate regression approach to a standard error estimation. And I showed you a method to do that with Hayes and Kai 2000 method, which involves running a macro and then calling the macro in SPSS, for example, and other programs do similar standard error corrections. So those are the steps involved with conducting a bivariate regression, whole and complete, professional level if you want to consider it in that context, and will allow you to write a manuscript if you're very focused on the bivariate regression.